Okay, let's talk about reverb types. Now, in hardware, we could have always recorded a reverb simply by placing a sound source in a room or placing a speaker reproducing a sound in a room and then two mics record that, get a stereo reverb, or use one of the hardware reverbs made back in the days, like plate reverbs, which used to play the sound through a metal sheet. So basically what they did was attach that driver that you have on the back of your speaker to a large metal sheet, and actually instead of moving the cone of the speaker, it would move that really large metal sheet, just vibrate it. And then on equal distance from that driver that was moving the metal sheet, we had two pickups, like the ones from the guitar, like contact mics. So those would detect the vibrations in the plate and thus create a reverb effect. Now, that sounded quite differently from the room, since sound traveling through metal travels quite differently. You know, the high frequencies travel faster through metal. So we got a really distinctive reverb, that plate reverb, and it's being emulated through so many plugins today in software. Now, in software today, we do have two types of reverbs. Algorithmic ones, which actually, as I said, emulate halls or plate reverbs of many different types of reverbs, but they do that by using mathematical equations. So trying to calculate all of the different reflections that would happen in a room of a certain size with a certain material on the walls, or let's say a plate reverb, so sound traveling through metal sheets. So algorithmic would be the ones that do that through mathematical equation. We also have impulse response reverbs. Now, the ones that you've seen so far in the lesson have all been algorithmic, like the one from FabFilter I showed you, like this one, or the one from Ableton. The standard reverb from Ableton is also algorithmic. Now, we also do have convolution reverbs, or as the other name would say, impulse response reverbs. Now, why? Convolution reverb uses impulse responses. So an impulse response, what it is actually, and let me show you one. It's a sound, but it has been recorded in a room by playing a single digital pulse. So if you remember in that sampling rate, it's a single digital pulse that if we had all those samples in a row, 44,100 of them, now this pulse would last only one sample. So imagine that really short click that would be played, and then what we would record is what the room did with that one click. Now, convolution is a process that could use a file recorded like that. The convolution reverb and the convolution process could use that file to apply that same effect of what the room done to that one impulse to any sound we play through it. Now, this is what the impulses sound like. Now, those are from plates, the plate reverbs, as I told you, and these are from the real plate machines. Let's listen to one from halls. So these are all just sounds of a sound, a really short digital impulse being played in a hall. This one specifically is from a machine called BM7. So we have many different impulse responses recorded, mainly from gear, from hardware reverbs, or from actual rooms. And we can use those in convolution reverbs. So I can import any one of these impulse responses, like let's say real spaces. So these are from Real Spaces, German concert hall. Let's hear that. So these left and right were actually recorded with dual microphones so that we would get a stereo reverberation effect from the actual room it was recorded in. Now, with all this talk, let's just hear what they sound like. I have right here a plate reverb loaded from one of the plate machines. It's from an EMT 250, a device from the so-named company EMT that actually had a patent on these plate reverbs. So let's hear what that sounds like on a snare. Say this snare right here, solo that out, and I can add that reverb by just adding that send D to this snare. So let's hear it without and then with. I'm gonna add the reverb later. Nice. Let's hear some of the real places. Let's take a giant basilicum like this. Yeah, that's a really large hall. Let's see what else we have. Seminar room. Let's take one of those. We have cathedrals. Let's hear this one. Yeah, it really sounds realistic. So all of these impulse response reverbs, they sound realistic, but they can be really tough on your CPU. So the convolution process really is hard on your CPU, so don't use too many of these. Now, as we talked before in the digital audio workstation lesson, we can use all of these reverbs on actual return tracks so that we can send sounds to them and they just return the wet piece of the signal. So we can use basically one of these with one impulse response for many sounds. We can load, let's say, 4 or 5 of them, but use them on the entire song, on many different sounds, or even send one sound to a couple of these at the same time. Let's see a wooden room. Let's see what that sounds like. So really realistic. Now, we have other options inside of this delay. We can add some pre-delay to it. We can change the size of it. And these are just some things that this convolution reverb actually adds to manipulating these impulse responses. We can change the decay, so make it last longer. See that? Or maybe shorter. Make it mono, so we can make any of these reverbs mono, and there is a reason we would want to do that. Some elements in your songs could greatly benefit from a mono reverb. Now, outside of this one, the convolution reverb, we have right here in Ableton, and we do have an advanced version of that. Let me just check that out. So Convolution Reverb Pro, and this one has some added functionality. So we can actually load 2 of those, A and B. And right here we also have the actual selection drop box from all the impulse responses we have. So we can choose plates, bigger spaces, halls, whatever we had, and then choose one that we had in that folder you just seen. And we can do the same thing, let's say for the B one, and use both of those in conjunction. So we can use the split, have them early and late. So we can have early reverberation from one of those impulse responses and then late from the other. So more functionality than in the first one. We also have an EQ that we can apply to this reverb. After the fact, positioning, we can make it more to the left, to the right, off center, and have some modulation. Damping also, we can choose to have, like, let's say the low frequencies last shorter in the decay, and then let's say have the high frequencies last longer in the decay. You can see that it's actually changing this spectrum as I move these points, like an EQ point, but these actually work in time. So the time duration of the reverb on the low frequencies is going to be shorter now, and on the high frequencies is going to be longer. That's what I'm affecting. Also, we can affect the shape of the reverb. Now, this is just one of the convolution reverbs we can use. I have other ones too. So let's say IR. We do have more of those in, let's say, waves, just like this. Let's say full. Now, this reverb also really nice from Waves, impulse response reverb. You can load your impulse responses, and as I've seen, it's been updated, so up to 8 seconds. So we can load any of these impulse responses we have anywhere. So even the ones that were provided for another convolution reverbs, those impulse responses don't actually change. They are the same for any convolution reverb. So it's just a WAV file recorded in a room, and we have played that short digital impulse. Now, it doesn't have to be a room and record it with a mic. We can record the same thing using convolution process, but through an actual piece of gear. Now, aside of being able to use convolution reverbs as it is easy, So you just load the reverb, load an impulse response into it, and that's it. So you just choose an impulse response, drag it in, done. Same for the waves, same for this one, same from almost all of them. Now, what we can do also is record our own impulse response reverbs. So it's not such a big science if you're not using the real room. So what we could do is actually, I will create a new project like this, and let me try to create an impulse response for us, just to show you how it's done. So I can use this IR measurement device, let's say on any audio track, just like this. And let's say I wanted to create an impulse response from this reverb. So I wanted to recreate this reverb in here, which is really silly because I already have it. So it would have been smarter if that was a piece of hardware that I don't have, so I could go somewhere to a friend of mine that actually has a piece of hardware, record impulse responses from his fabulous, really expensive reverb, and just use them in my impulse response reverb, so convolution reverbs at home. Now, what I could do is actually use it like this. I'm going to be recording on the same channel, and as an input, I'm going to use the actual master. Yeah, just like this. Yep. So what this IR measurement device is going to do, it's actually going to produce that impulse sound. And I'm going to play that through this reverb and record what's coming out, because that's going to be coming out on the master track. And I'm going to record that back into the same device. So he's actually going to create an impulse and record what's coming in at the same time. So I put it on a track, put the reverb right after it. It's going to produce the sound. It's going to go through the reverb, out the master, and I'm recording what's coming out the master right here on the input of the same device. So true stereo, as I can record, let's say, mono to stereo, I can record only one impulse response, and that's going to go to the left and right tracks. If I record true stereo, it's going to record two separate impulse responses on the left and on the right track, thus creating a real stereo. So let's see what that sounds like. I'm going to click the impulse. It's going to create an impulse. You will see it happening here. That will propagate through the master channel, and I'm going to record that because that's the input of this one. So let's do it. Now what I also have to do is turn on the auto right here so that I could hear the impulse response on the master, so that I could hear what I'm recording on the input, thus actually hearing my master, thus it actually going into the measurement device so that we could record the impulse response back. So let's see what that sounds like. Let's record the impulse response now. See, one on the left, and now it's going to do on the right also. Bam, on the right, recording what's happening on the input. And we have that impulse response right here. So we can say save, give it a name, reverb 1, done. And now, as those being audio files, I can load them into my Ableton. Let me do that there on my desktop. So this is what they look like. Just impulse responses, just like the ones that we've seen. So let's use them in the context of that song I actually played you before so that we can hear what they sound like. Now, as you can see, I have the same thing. So I have this convolution reverb right there on that send track, and I'm going to pick up reverb convolutions that I made, reverb 1 and 2, from my desktop. They're recorded as AIF files. I'm just going to drag them from my desktop folder, which is on the other screen. You can't see that, but I'm just going to drag them right here. So it's not rail files. And this is what they are. Reverb 1, left, right. So he took the left and the right, recognized the naming, and this is what our reverb sounds like. So let me put this all the way to the wet, just play with the snare, and add some reverb that we just made. So this is the reverb we recorded from this reverb device just now, meaning that it's really easy to make these, and you can make these from any kind of hardware or software. So let's say you could try to circumvent somebody having software that you don't, and you could go to your friend's place and record impulse responses that you liked from his reverb, and then just use them like this in a convolution reverb. Now, that's as far as the explanation for convolution reverbs go. The algorithmic ones, as you've seen them, they have many more of those parameters that you can set, but that's basically because they operate on a mathematical function. So you can actually set all of these parameters and they just change variables in a mathematical equation that actually produces all of the reflections that the room we are trying to emulate would produce. This is why they are more complex with more settings. Usually convolution reverbs have settings, not as many and not so precise, but it is because you do want to use that impulse response you recorded and reflect that room that you recorded in as real as possible manner that you can. So to finish this off, convolution reverbs or impulse response reverbs, they sound much more natural and you can use them a lot, but there is no harm in algorithmic reverbs. They also produce wonderful effects. So your taste is usually what you want. So convolution reverbs would actually give you that realism of space of a room. But if you wanted a special effect of a really big space that you can't find in nature, then you would actually use an algorithmic reverb. Or you could use a convolution, so an impulse response recorded from an algorithmic reverb if you don't have that reverb with you. So you could actually use convolution technology to replicate any other reverberation device.